All right, let's talk about that feeling. You know the one. You feel like you're wrestling this beast of asynchronous events. You've got user clicks over here, API calls over there, WebSocket messages coming in. It's a lot. Today, we're going to learn how to tame that beast with RxJS. But we're not just going to memorize syntax. We're going to adopt a whole new, powerful way of thinking about the problem.
I mean, we've all been there, right? You're juggling all these moving parts in your application. You try to coordinate them, and before you know it, you're lost in this tangled nightmare of callbacks and complex state management. It's the perfect recipe for spaghetti code. But what if there was a way to turn all that chaos into something, well, calm and predictable?
Okay, so how do we actually do that? How do we get from chaos to clarity? Well, here's the game plan for this explainer. We're going to start by really defining the problem we're all facing. Then we'll introduce the core stream philosophy of RxJS. After that, we'll dig into the brilliant computer science concept that makes it all possible. We'll use a fun analogy to understand its different flavors. And finally, we'll lock it all in with a simple mental model you can start using right away.
Right. Let's dive into asynchronous chaos. And look, this isn't just some buzzword we're throwing around. It's a real thing. Think about it. You have a search bar. The user is typing, and you need to make an API call. But wait, they typed again, so you got to cancel that previous request. And what if they just click away before any results come back? That is the kind of messy, real-world complexity we're talking about. And it gets even crazier, right? Picture this. A user is clicking all over your app, setting off a chain reaction of API calls. At the exact same time, a WebSocket is pushing live updates for a little notification badge, all while you're trying to keep an animation running buttery smooth. Every single one of those is its own asynchronous thing. Trying to stitch them all together? That's a surefire way to create a tangled mess. And even worse, you might forget to clean up your event listeners, which leads to those really nasty memory leaks. So, what's the RxJS solution? Well, what's so interesting is that it doesn't just hand you more tools to try and juggle everything. Instead, it offers a fundamental shift in perspective. It asks you to take a step back and completely change the way you see the problem in the first place. And this is the big question. This is the light bulb moment. What if you treated everything as a stream of values over time? Think about it. What if a user's clicks weren't just a series of separate random events, but a continuous stream of data flowing right through your app? What if an API response was just a stream that, happens to spit out one value and then it's done? This one simple shift in perspective, it's the key that unlocks everything. And that's exactly what RxJS is all about. It's a library that gives you the tools to treat pretty much everything, clicks, promises, timers, you name it, as something called an observable stream. And the result? You get one single, unified, and incredibly powerful API to manage all of it. Okay, but where did this whole observable idea even come from? It's not like it just popped into existence out of thin air. To really get why it works so well, we've got to look at this really brilliant insight from the world of computer science that's at the very heart of it all.
Yeah, this quote right here from Eric Meyer, he was one of the geniuses behind the original reactive extensions at Microsoft. This is basically the secret sauce of RxJS. He had this amazing realization that two of the most fundamental patterns in programming weren't just different, they were perfect opposites, like mirror images of each other, two sides of the exact same coin.
So, first, let's talk about the iterator pattern. This is what we call a pull system. The buffet analogy is perfect here. You, the person eating, the consumer, you're in complete control. You decide when to go up and get another plate of food. You pull the data when you're ready for it. The data itself, the food, it's just sitting there, totally passive, waiting for you to ask.
And on the flip side, you have the observer pattern. This is a push system. And yeah, the pizza delivery analogy is spot on. You've placed your order, and now you're just waiting. The pizza place, the producer, is the one in control. They decide when the pizza's ready, and they push it out to your door. All you do is react when it shows up.
So it really boils down to this. In a pull system, the consumer's in charge. In a push system, the producer's in charge. The whole game is about who's driving the data. And understanding this duality is so important, because what RxJS did was find a genius way to combine them. And this is where it gets really, really clever. An RxJS observable masterfully fuses both of these patterns. It has the lazy, pull-style nature of an iterator, meaning nothing actually happens until you ask it to, but once you kick it off, it pushes values to you just like an observer. You seriously get the best of both worlds. Okay, so now that we know what an observable is, there's one more layer.
See, not all of them behave the same way. They really come in two main flavors, depending on the data source. To make it super clear, we're going to use a really simple analogy: Netflix versus live TV.
This table here lays it all out perfectly. A cold observable, think of that as Netflix. When you hit play on a movie, you get your very own private screening that starts right from the beginning. Every single person who subscribes gets a brand new, fresh execution. Now, a hot observable, that's live TV. The Super Bowl is happening right now, whether you're watching it or not. When you turn in, you're just jumping into a single, shared broadcast that everyone else is already watching.
So the bottom line is super simple. Cold is one-to-one. Hot is one-to-many. A cold observable is a direct, private line between the data source and the listener. We call that unicast. A hot observable is like a radio tower, broadcasting its values out to everyone who's listening. That's multicast. A great example of a cold one is an HTTP request, and a perfect example of a hot one is something like mouse clicks on the main document.
All right, we've covered a lot of the why and the what, so let's get practical. How do you actually put this stuff into practice? Let's wrap this all up with a really simple 3-step mental model that you can use every single time you work with RxJS.
And here it is. This is the whole workflow in a nutshell. Step 1, you create an observable from a source, like a button click. But here's the key. This is just a blueprint. No work has been done yet. Step 2, you transform it. You build this pipeline of operators to shape the data as it flows through. And finally, step 3, you consume it by subscribing. Subscribing is the trigger. It's like saying, okay, run the blueprints, and that's what sets the whole thing in motion.
And this workflow really hammers home 3 super important principles. First, RxJS is lazy. Your observable is just a plan on paper until something actually subscribes to it. Second, your transformation should be pure. Think of operators as a clean, predictable assembly line for your data, no side effects. And third, all the messy, real-world stuff, like updating the DOM or logging to the console, that belongs inside your subscription. This clean separation of concerns is what makes your code so much more maintainable.
And you know, this is the ultimate payoff. This is why it's so powerful. RxJS gives you a universal translator for asynchronous data. You can use the exact same set of tools, the same operators and patterns to manage mouse events, GPS sensor data, or API calls. It doesn't matter where the data comes from. You learn the model once, and you can apply it absolutely everywhere.
So, I'll leave you with this final thought. Once you start seeing the world through this lens, once everything starts to look like a stream, you'll start spotting problems you can solve in totally new ways. Ways that are cleaner and way more powerful than you ever thought possible. So the real question is, what are you going to build with this new superpower?